Hello everyone, you are watching e-learning classes with me Siddhartha Dev and you are most heartily welcome to my e-learning classes. Today also I am here to discuss and requisite topic from the science book of grade 9 students, and you can see under the topic today we will be discussing regarding the derived unit. Here today we will learn how we can express the derived units in terms of the basic and fundamental terms. So that simply we call derivations of the derived units in our text. So let's see how we can achieve the fundamental terms involved in any derived quantities. Before that, we must see some of the example of derived quantities along with their units so that we can derive them one after next. So see derived quantity and their units. Okay, firstly see area. Okay, you have done lots of the exercises regarding these properties. We simply write its unit as meter square, and in the same way speed, it is also example of the derived quantity. Okay, and you write its unit as meter per second. In the same way acceleration. Okay, can you remember the units involved in the acceleration? That is meter per second square. In the same way see force. Okay, simply when you write the unit of force, you write by the capital N, symbolize with the Newton's first letter, but when you need to express it totally in terms of the fundamental basic terms, you must write kg meter per second square. In the same way, see now energy. Okay, simply energy you express it by the capital J. Okay, simply energy you can express it by the capital J, first letter of the joule, and if you need to express it again in form of the fundamental terms, you can express it as kg meter square per second square. See now, these are the units of derived quantity. So today we will learn how we can get this type of the unit, okay, for each derived quantities. So let's begin one by one. We will see. Now let's see. Let's start with the easier one, that is area, that we use here for the derivation. See now, formula of area is length times breadth. Keep the habit of expressing the formula in the long form. Okay, don't write it short form L and B, just write here complete words deriving these units. So length and breadth both are in the fundamental terms. We can write their unit as meter times meter. So see here, when you condense this together, you will get meter square. So by the help of formula, we can derive the units involved in any derived quantity. Okay, but you must know some formulas, okay, that we will be using for derivations. So let's see the next example. I will take you to the next example is speed. See now speed, remember the formula of speed. If you know the definition also, you can just convert it into the formula. Speed is the rate of change of distance, that we can write distance by total distance by time taken. Simply we can write distance by time taken. Yes, so it means distance is in fundamental terms, time is also in fundamental terms. We can write meter by second. When you will condense this, you will get meter per second. So simply see, by writing the formula we can express it, okay, in terms of the fundamental units. So let's see the next example, little complicated one, force. Okay, see over here, according to the Newton's second law of the motion, force is well defined in terms of the product of mass and acceleration. So you can just write over here mass time acceleration. Okay, see, I already said try to write in the complete form. Okay, it will take little more time. Okay, but you will be able to do very nicely. Okay, now let's see mass is in fundamental terms. So we have here acceleration, which is not in fundamental terms. So our main theme is to, our main work is to now convert all these terms in the fundamental unit, okay, fundamental quantity. So see here now, unless and until you get the fundamental terms here, you cannot get the fundamental unit. Okay, you have to understand that anyhow you can use any formula, but you have to change all the terms in the fundamental quantity so that you will get the fundamental unit. So let's change it, keeping mass same as it is. Acceleration means velocity by time. So see now again mass and time are in fundamental terms, but velocity is in derived terms. So we need to again, okay, furthermore we need to change the velocity here so that you will get mass times, see now I am writing mass and time as it is in the previous equations, just I will change the velocity by its formula, that is displacement by time. So when you arrange this again, you will get the equations like this: mass into displacement by time into time. See now here you got the mass into displacement by time into time, all are in the fundamental terms, no need to change furthermore, just now you can, okay, change their units. See now kg, unit of displacement is meter, time is second, and this time is second. So when you condense this, you will get the structure like kg meter per second square. See now in this way we can convert, okay, the units of any derived quantity in terms of the fundamental units. So let's see now next also one more example how we can derive the units as a whole. You just need to understand the mechanism here with the help of the formula, how you do step by step, okay, how you come to the fundamental terms. Okay, just you need to achieve the condition where your all terms will be, okay, similar to the fundamental quantity. So let's see the next example, pressure. Pressure is defined as the force per unit area. We are well known about it. Force per unit area, you have read so many times. So force and area both are in the derived term, okay, they both are not fundamental term, means we need to change both. Force I can write mass into acceleration. Now area I can write length times breadth. Now see which terms you got in the fundamental and which terms you need to change here. See now mass, length and breadth all are in the fundamental terms. Acceleration I need to change, so I will keep this mass, length and breadth same as it is in our previous equation, just I will change here acceleration by its formula, velocity by time taken. Okay, now look at once again here, rearrange it, you will get mass times velocity by length, breadth and time. You will get in the downward length, breadth and time. So now again see whether these all terms are in the fundamental quantity or not. See here now velocity is still not fundamental quantity, it means we need to change velocity. I am directly changing here, okay. So I can write velocity displacement by time taken. Again when you will arrange this, you will get mass times displacement by length into breadth into time into time. So look here, now I can see all the terms are already arranged in the fundamental quantity. So I can just replace them by their unit. See now kg, displacement unit is meter, and length breadth unit is meter, and 2 times are there, so second into second. Now you have to see whether there are any terms that can be cancelled or not. If they will be the cancelled, we can cancel them, and remaining, if you will condense, you will get kg per meter second square, kg per meter second and square. So this is our unit of pressure. Simply you can write the unit of pressure is Pascal, okay, as well as you can write Newton per meter square, okay, but they are not in terms of the fundamental unit. So if you need to derive the unit of pressure in terms of the fundamental unit, you can see the process, okay, and finally you will get the unit involved in the pressure, that is kg, meter and second, okay. So in the same way we can derive more and more units of derived quantity, okay. Let's see one more example so that you can be clear and you can derive by yourself, okay. So now we will do energy. See, energy, simply energy means the work, okay. Energy means work, you have already learned, okay. And similarly both unit will be the same, both formula will be the same, okay. So derivation of energy means we are deriving the unit of work also, both are similar terms. So what is the formula of energy? There are so many formula of energy, okay. In the same way work, if you see the work and energy, they both are similar, so I can write the energy is the product of force times displacement. You can use the other form also, other form of the energy also, like formula of kinetic energy, formula of potential energy, okay. You can use any one of them. So now let's see force into displacement. Force means the product of mass into acceleration, so you can write mass into acceleration into displacement is here. Now see, mass and displacement are in terms of the fundamental quantity. Now you need to change the acceleration only, so you can write velocity by time into displacement. Now look at here, if you arrange this, you will get mass into velocity into displacement by, you will get time. So see over here now, they all are in the terms of fundamental quantity except velocity, okay. Means we need to change the velocity, so I will be changing here. You can change in next step also. So let's see, displacement by time. So when you again arrange this, you will get mass into displacement into displacement by time into time, time into time. Okay, now just see all are in terms of the fundamental quantity. Now what we can do, we just replace it in terms of the unit. So see here, kg times meter times second times second. So there are no any terms for cancellations. Okay, so we need to just condense them. Okay, as we get here kg meter square per second square. See now, finally we got the unit of energy also. So in this way we can derive the units, fundamental units involved in any derived quantity. So this is the most important question also, which are repeatedly asked in our examinations. Okay, derive the unit of energy, derive the unit of work, derive the unit of pressure. So just you need to remember some basic formula while deriving this process. So I hope you can do very well in your examinations if same question will be asked there. So by this I like to thank you everyone for watching me.